understands what to do with it, and it knows, let's say, to save what you wrote or to print what you wrote or whatever it is. When you use the application, let's say you type and you tell it to save or something like that, the instructions are sent to the central processing unit. So again, it's hardware, but the CPU, and this does what you are telling to, or rather what the application says that it should do based on your instructions to it, to the application. The application sends it to the CPU, which says, okay, I know how to deal with this. I know how to like store this. I know how to, let's say, put this other thing on the screen. That's what comes from the CPU. Sometimes it requires storing information temporarily. Like, for example, you're typing in Microsoft Word and you click around a few things, you change certain, let's say, you change the font, you change the color, and the last few instructions are saved without you necessarily knowing about it. This is usually in the RAM. It's saved in the RAM. It's a common thing that a person has a certain instructions, they want to undo it. Let's say they deleted something, and then they realized, I don't want to delete it. Well, the computer has saved what you did and saved your deletion in the RAM so that you can undo it. The Microsoft Word will allow you to undo it, but it can only do it if it saves it, if it saved your last few instructions. So some things are actually saved in the RAM without your even knowing. If something has to be saved permanently, then it's saved on a memory device like a hard disk drive. This is a very valuable part of the computer, whereas for forensics, because these things are permanently saved there. We want to get that information because there is a lot of evidence there. Things that were written, that were typed, that we want to know about are going to be on the hard disk drive. We have to now understand a little bit more about the hard disk drive. So most of the information that the computer uses, including the applications that are used, is on the hard disk drive in the form of various files. Again, that's why the hard disk drive is very valuable. If the computer is going to be destroyed, make sure, or is going to be broken, or is going to be taken apart, make sure you keep that hard disk drive undamaged. What it can do, it can gain partitions. A partition is a part of the hard drive that the computer will use in a given session, not another session necessarily. A person can partition it and say, I like Windows for only certain parts, things that I do, so I'm going to partition it. I'm going to only use Windows on a certain day. Other days, no, I like the way the Unix system, the Linux, let's say, works. So I'm going to use a different part of my computer to work with the Unix or the Linux. So a person can do that. A person can partition in their hard drive for various reasons. But generally speaking, a person would have, let's say, one partition that they work with usually. So, again, it's good to know what the partitions are. The main thing, however, is the partition that it's formatted. I mean, you might have formatted your disk, you might have formatted a disk, you might be familiar with that. The idea is it's put into a very organized way, files that are put into a very organized system. That's when you format it. They're organized into tracks, clusters, and sectors, and the file system has to know how to navigate the tracks and the clusters and the sectors to get your file, the file that you request, and use it using whatever application you might want to be using. So the file system has to be able to retrieve the file. Let's take a look at how file systems work with the hard disk drive. Hard disk drive, if you open it up, you'll actually find real disks. You don't just find, let's say, one disk, but you'd find, let's say, like a bunch of them, let's say 8, 4, whatever it might be. We're just going to look at one, and they're all kind of the same for our purposes. So the track is one of these concentric circles that go all around the entire disk. That's a track. So the computer can look at it, and it knows I'm going to look in this track to find the file. The main thing that we're going to be trying to learn and trying to understand and work with are the sectors and the clusters. You save something, it will go into one of these sectors, right? It's within a track, and here's one sector. You saved in one sector. A sector has, let's say, 510 kilobytes. Let's say your file has only 200 kilobytes. It can be saved within one sector. Let's say your file, you want to save it, and it is, let's say, 1,000 kilobytes. It's going to have to be in more than one sector. It'll be in a cluster, like a sector and hopefully a contiguous other sector. But these, when they're together, they're called a cluster. Let's say you might need 3 sectors for one file. Again, this is like probably you're gonna have more than this, but anyway, you have 3. Then you have the cluster of 3 sectors. Your file might occupy 3 of them. It's possible that a file or a group of files might not be able to get this. This might be occupied. So you'd have this cluster, and you have to have it somewhere else. This is what leads to what they call fragmented files. The files on the file system. And again, it's hard for the computer to locate the file or group of files when it has to look in one place and also get information from another place. So that's why people advise you to defragment your drive. So all your files are in contiguous clusters, not in a sector here, a sector there, a sector there. It's easier and faster for the computer to work that way. When files are deleted, they go nowhere at all. All that means when you delete a file is that the computer now knows that, let's say you deleted a file over this file over here. The computer just knows that I can rewrite information over here, but the data is not lost. So that's an important thing to know about deleting files. Deleting files does not mean it's gone. It just means that when the computer needs space to write other files, it can use and often will use that space. RAM, however, if you remove RAM, let's say when you turn off the computer, that is completely gone and cannot be retrieved. However, sometimes without the person's knowledge, RAM is actually put into the hard disk memory, and that can be retrieved. So that's done in the idea of the swap space. RAM, the computer is constantly, let's say it's constantly showing the screen, it's constantly doing things in the background. If a person uses Windows, there are some programs running in the background. This is managed with the RAM. Now, sometimes if you're not using, let's say there's a window in the background and you're just not working with it, the computer recognizes this and says, why am I using up my RAM, the active RAM for this stuff? I'm going to save all the information, all the RAM information from that window that's not being used, and I'm going to save it on the hard disk drive. And when he clicks on that window, I'll know, okay, now I get that stuff back in RAM. I'll look back on the hard disk drive where I saved that RAM and the information that the RAM was required. I'll bring it back, and then I'll put it in RAM. So I don't constantly have to use RAM on processes and Windows that are not being used. RAM, the more RAM that's being used at the time, the slower the computer is. So if it's not being used, the computer will say, hey, I'll just dump that I'll save that in a hard disk drive, and I won't be using that RAM. That way everything else will go faster. Very, very convenient and a very efficient way of working with RAM. But the point is that sometimes RAM is actually saved on the computer without the person knowing. It's saved in a place called what they call swap space. Some place on the computer that RAM has been saved. Now, the active RAM is not necessarily saved, but RAM that's for certain windows or certain processes that are really not being active, that might have been saved. So a person gets an image of the disk. What that means is an exact copy of every single file, including the deleted files, including the files in the swap space. That's an image of the file. And if a person gets that, the forensic computer analyst will get that. They're going to be looking in the swap space to say, hey, what are we missing? What was in the RAM that we don't have, that we can't catch